AB Calculus BC, Unit 7, Day 7, Office Hours. This is actually Part 2. This time we're going to do all shells. So we're going to do dx or dy, but we're going to make sure we do all the shells. Part 1, we did all disk and washer approaches, but you guys also need to do the shells. So we already have answers we can kind of check against. We should get the same answers. Extra credit for evaluating the intervals by hand. You should do them at least by calculator and see if you get the right answer that way. That's an easy way to check it. Check your answers from the other one, the other approach. So first thing to do is draw the picture. So we have y equals x squared. Make sure you revolve it around the correct axis. And so if you want to get shells, you have to slice parallel to the axis of rotation. So this is the axis of rotation. It needs to be sliced parallel to the axis of rotation. So that gives you a shell. Now the volume of a shell, if you take a shell and you know, this is like a single shell. And if you slice it open, you get a rectangle. And so the area of this rectangle times the thickness gives you the volume. Now this rectangle, that top dimensions of the rectangle comes from the circumference around the shell. So that's going to be 2 pi r, circumference around the edge of the shell, times the height, which is sideways this time, dy, because it's a horizontal slice. The limits are going to be in the y direction, 0 to 16. The radius is y top minus y bottom. It's not dependent on the curves because it touches this, touches this. It's just going to gradually change as y changes. So it's going to be y minus and y bottom is 0. So it's just going to be y, which is pretty typical of shells, just x or y, possibly plus or minus a number if the axis rotation is not on the x or y axes. The height is where the curves come in. X right minus x left. So x right is always 4. X left right here in terms of y would be positive square root of y. That's your x left. So it's going to be 4 minus the square root of y dy. So that's your setup. And we could plug that in our calculator and should get the same answer we got when we did disks and washers. If you're going to integrate by hand, you should probably go ahead and distribute this for y minus y to the 3 halves. And then we're going to get antiderivative is for y squared over 2 minus y to the 5 halves divided by the new exponent multiplied by this reciprocal. 0 to 16, that's a 2. So we have 2 pi. If we're going to plug 16 in, 16 squared is 256. What was that? 512. Minus the square root of 16 is 4 to the 5th power is some large number. 4 to the 5th. 4 times 64, so 24, carry the 2, 38, 0, 4, 6, 4, 12, carry the 1, 10, 24. Plug 0 in, and we get 0 minus 0. So least common denominator would be 5, right? So multiply top and bottom by 5. So we have 2 pi, 2,560 minus 2,048. It's actually not going to be too bad. So was that going to be 512? So 1024 pi over 5 is your final answer. And that is the same answer we got when we did shells, but we could, let's see, let's figure it. Let's do this on character. 2 pi, math 9, x, parentheses, 4 minus the square root of x, comma x, comma 0, comma 16. So this should give us the decimal answer. 643.398, which is what we got before. And just to double check, 1024 pi divided by 5 is the same thing. So it's good. All right, that's the way you can check your answers if you're doing them by hand, and then check them against the other method, see that you get the same decimal. Find the volume solid. So this is the top half of a sideways square root. This is 4. This is your original region. We're going to spin it around the y-axis. Be careful. Make sure you actually pay attention. It's even harder when they don't give you the picture. They describe it in words. Okay, so if we want shells, we want to slice it parallel to the axis of rotation. And the volume of a single shell is 2 pi r h dx. Do not memorize that formula, just make sense of it. It's the circumference, 2 pi r times the height. So the radius does not depend on the curve. It's x right minus x left. X left is 0 here. It's just going to be whatever x value we're at. We're just gradually changing the radius from 0 to 4. So whatever the x value that we're at in the middle of our integration, that's your radius. The height is y top minus y bottom, and y top in terms of x is the square root of x, y bottom is 0. And we're integrating the x direction, 0 to 4. Always integrate from edges of the original region, never over here. So I would rewrite this as x to the 3 halves. Antiderivative is going to be x to the 5 halves divided by the new exponent, 0 to 4. We could write 4 pi over 5. Plug 4 in. Square root of 4 is 2 to the 5th is 32. Put 0 and you get 0. So we're going to get 128 pi over 5 for our answer, which matches what we got when we did dishwashers. We're going to plug this into our calculator, or that version. So this is going to be 2 pi, math 9, x to the 3 halves. Now, if we're going to do that, you got to put 3 halves in parentheses, or just write 1.5, comma x, comma 0, comma 4. And we get 80.424 or 80.425, and 128 pi divided by 5 is the same thing. So we're good. All right, this one right here, we rotated it right here. This is the equation of a circle. If you plug 0 in here, this is going to be 3, 0. It's going to be negative 3, 0. So the radius is 3. This is going to be 0, 3. This is going to be 0, negative 3. So if we slice it parallel to the axis of rotation, so we did this one the other way, and by the way, this is a sphere, right? So we should get the same answer from a sphere. The volume is 2 pi r h dy. The limits are going to be in the y direction. So this is original region. So we're going to go 0 to 3. The radius is y top minus y bottom. Y bottom is 0. Y top is just whatever y value we're at. This is your height. The height is x right minus x left in terms of y. So we need to solve this equation for in terms of y. So we would square both sides. Y squared equals 9 minus x squared. You get x squared equals 9 minus y squared. Take the square root of both sides. Plus or minus. We're going to actually use both of them because x right is the right side of the circle and x left is the left side of the circle. So it's going to be positive square root of 9 minus y squared minus negative square root of 9 minus y squared dy. That's your setup. Now, we clean this up. You're going to have 2 of these in here. You can bring that 2 out for 4 pi y square root of 9 minus y squared dy, 0 to 3. That'd be a little easier to type in your calculator. As far as integrating this, I think we'd have to use u substitution. U equals 9 minus y squared. Du equals negative 2y dy. I don't want the negative 2. So you get 4y, and then you'd have another negative 1/2 in front, and then you would have the square root of u du, which would be negative 2y, 2 pi, u to the 3/2, negative 2 pi, u to the 5/2, multiplied by the reciprocal. Change it back to in terms of the original variables. So that is u equals 9 minus y squared to the 5/2 power, 0 to 3. This one's kind of rough. So if you plug 3 in here, you get 0. If you plug 0 in here, you get 9 squared 9 is 3 to the 5th power, 3 to the 5th power. Whatever that is, that's going to be what, 9 times 27. I think it's like 243, right? So this is going to be positive 243 4 times 243, 12, carry the 1 to 16, 17, add 1 to 8 is 9. So it's this positive 972 pi over 5. It better come out positive. Now, it looks like I made a mistake somewhere. Trying to figure out. Oh, this should probably be, you're going to add, no, that's 5/2. That should be right. So, let me see. Let me check my work right. Okay, I made a mistake here. This should have been 1/2. So this should have been 3/2. So this should be 2/3. So that should be 4/3. That should be 3/2. And that's going to be 0. And so plug 0 in. Square 9 is 3 cubed is 27. So it's going to be 4 times 27, which is 108. Which still does not seem. Oh, but this is a 3. And 108 divided by 3 is 36. So the answer should be 36 pi. I got hung up there a little bit. Let's see if we can match this answer. 2 pi, math 9. I'm just going to plug in, or yeah, I don't know. Let's go 4 pi, math 9. X square root of, this is all inside, 9 minus x squared, close parentheses, on the square root, comma x, comma 0, comma 3. Gotta wait for it. 113.097, round trying to get 3 decimal places the same. Let's check. 36 pi is the same thing. Okay. Got a few more on the back. So let's draw our other half. It looks like that. This is original region. We want to slice it parallel to the axis of rotation. To get shells, the volume of one shell is 2 pi r h dy. We're going to integrate in the y direction 0 to 4. The radius is going to be y top minus y bottom. Y bottom is 0. It's just going to be y. The height, this is where it gets a little interesting. X right minus x left. We got to get this equation in terms of x. So it's going to be positive square root of y. So it's x equals plus or minus the square root of y. The right half over here, x right, is positive square root of y. The left half over here, x left, is negative square root of y because it's the left half. So it's minus negative square root of y. So it's going to be 2 square root of y dy. It's the right and left half of the same curve. So that's our setup. To do it by hand, I'll probably bring the 4 out, change this to y to 3 halves. 4y, antiderivative is going to be 5 halves divided by the new exponent. 0 to 4, 4 pi, 2 fifths. If you plug 4 in your square root of 4 is 2 to the 5th is 32, minus 2 fifths, 0. So we get 8 times that, so it's 248 pi over 5 for the exact answer. And that's the same answer. Oh, actually, 8 times that, that's going to be 256. Doing a little too much math in my head too quickly. So that should be the right answer. And then on my calculator, 2 pi math 9 x times square root of x, close, comma, x, comma, 0, comma, 4. Okay, I think I typed in something wrong. Let's see, 2 pi x. Oh, I put a x where I should have put a 2. Okay, let's try that. 160.849 or 160.850, 3 decimal accuracy, rounded truncated, and 256 pi divided by 5. Same answer. Good to go. All right. This one here has an offset axis of rotation, so that's gonna bring some numbers into your radius instead of just x or y. We want to slice parallel to the axis of rotation. And remember, everything's determined over here. The coordinate of this point is 1. Sine of pi over 2 is 1. So the volume of a shell is 2 pi r h dx, vertical slices this time. The limits are in the y direction, 0 to 1. The radius is x right minus x left. X right is pi, and x left is whatever x right. So we're going to have a pi minus x for the radius. The height over here is y top minus y bottom. Y bottom is 0. Y top in terms of x is sine x. So that is your setup. Now, to integrate this, the washer approach we couldn't integrate because it involved inverse trig. But I think, I don't know, you would, you guys in Calc BC can actually integrate this because it involves integration by parts. So 2 pi 0, 1, I would distribute this. This is where you're going to use integration by parts on this guy right here. This guy, I'm going to split it up. So we have 2 pi squared integral 0 to 1 of sine x dx, which should be okay, minus 2 pi square root of x sine x dx. This is where we're going to need to use integration by parts, limit. We have polytrig, which is good. That's a shortcut. You guys remember the shortcut? So you take the derivative of that repeatedly until it goes away to 0. And this part you integrate. So you get negative cosine x, negative sine x. And then you multiply positive, negative, positive. You multiply down by on the diagonal. So we have 2 pi squared cosine x. Over here is going to be negative 0 to 1. And then this is going to be minus 2 pi. So that the antiderivative here is going to be negative x cosine x minus sine x 0 to 1. So we are going to get negative 2 pi squared cosine of 1. Let's see. Did I? Oh, the limit should be pi over 2. Pi over 2 in the x direction. Pi over 2. Pi over 2. Pi over 2. Pi over 2. Cosine pi over 2 is 0 minus negative 2 pi squared. Cosine of 0 is 1. So we get something there, minus 2 pi. So this is going to be negative pi over 2. Cosine of pi over 2 is 0. Minus sine of pi over 2 is 1. Minus negative 0 times cosine of 0 is 1. Minus sine of 0 is 0. So those cancel. And we get, so we have 2 pi squared plus 2 pi squared. Looks like it did something wrong. Okay. So, I mean, from this, I'm getting 4 pi squared, but that doesn't, I feel like that doesn't match my answer. Let me just double check my work. Negative x cosine x minus sine x. Okay. Positive. Oh, shoot. There's my mistake. This is supposed to be negative. So this should be positive. So this should be positive. This should be positive. It should make a little bit of difference. Okay. So I don't know. Okay. So we have a positive 2 pi squared there. And then this would be, I don't know. I made a mistake somewhere. You distribute the, okay. All right. Let's see this. So I have 2 pi squared minus 2 pi. So it's a little different than my answer, but I still feel like there's something wrong. But let's see what we get. Let's integrate it on a calculator. 2 pi, math 9, parentheses, pi minus x, close, sine x, close, comma x, comma 0, comma pi over 2. What? Okay, something's, oh, that should be a pi. Try again. That's negative, which is clearly wrong. So, that looks right. And, oh, this should be pi minus x. Okay, let's try it one more time. I'm just typing it wrong. So I get 13.456. And then over here, that's my answer right now. 2 pi squared minus 2 pi. There you go. That must be the right answer. I must have had it wrong on my solution. So that is the right answer. Okay. All right. Last one. Okay, if we want shells, we're going to slice parallel to the axis of rotation. Volume of one shell, 2 pi r h dy. Limits are going to be down here. It's going to be 0 to 4. The radius of a shell is y top minus y bottom. Y top is 6 minus whatever y value we're at in our slicing. 6 minus y. H is x right minus x left. X right is the positive square root of y. X left is 0, so it's just going to be square root of y. So that's your setup for your shells. If you're going to do it by hand, you want to distribute this stuff. So it's going to be 2 pi, 0 to 4, 6y to 1 half minus y to 3 halves dy. The antiderivative is 6y to 3 halves divided by the new exponent, multiplied by the reciprocal, by the 5 halves, 2/5, 0 to 4. So we have 2 pi. 4 square root of 4 is 2 cubed is 8 minus 2/5. 4 square root of 4 is 2 to the 5th is 32. Plug 0 in, you get 4 times 0 minus 2/5 times 0. Those cancel out. Looks like least common denominator we're going to need is 5. So we'll multiply that by 5. So 2/5. 160 minus 64 over 5 is going to be 96. 2 times 96 is 180. 192 pi over 5 for our answer. Exact answer by hand, which matches what we got when we did the other way. Let's try it. 2 pi, math 9, parentheses, 6 minus x, close, square root of x, comma, 0, comma 4. By calculator, we get 120.637, which is what we got the other way. And 192 pi divided by 5 is the same thing. We did it. Hopefully you become a master at dishwashers and shells.